This lesson is about potential difference. So our title today is Potential Difference in Series. We should be able to define potential difference, describe a model for explaining potential difference in a series circuit, describe how to measure potential difference in a series circuit using a circuit diagram, and describe the link between potential difference of a cell and the potential difference of the other components in a series circuit. So we should write our notes in the Cornell note-taking system. And we'll begin. Potential difference is the push that makes electrons move. So in a conductor, a small potential difference will cause electrons to move. That is an electrical current. Whereas with an insulator, you require a large potential difference in order to make the electrons move. In this case, the insulator is air. Air requires approximately 10,000 volts of potential difference in order to jump 1 centimeter. So from that we can infer that these two objects are 1 centimeter apart, because the potential difference between plus 5,000 volts of potential and minus 5,000 volts of potential is 10,000 volts of potential difference. So why is it a bird does not get electrocuted when it stands on an electrical cable at a high potential? Well, if we consider the right foot, we have plus 30,000 volts of potential, and if we consider the left foot, it is also at plus 30,000 volts of potential. That means there is no potential difference. These are the same number. That means there is no overall push on the electrons left or right. Therefore, no electrical current. Whereas if a person were to grab the wire and also touch the ground, since the ground is at a potential of 0 volts, there would be a potential difference across that person of 30,000 volts. That would cause electrons to move through the person, in other words, give them an electric shock. So let's look at a model to help us understand the idea of potential and potential difference. So a cell is a device which can raise the potential of the electrons in a circuit. It raises the potential of the charge. We can complete our circuit showing that a bulb causes the charges to reduce in potential. A second bulb will also cause them to reduce in potential. So here we have an analogy of a hill or a slope. The potential difference up the slope through the cell is 6 volts. In other words, from 0 all the way up to 6. The potential difference across the first bulb is 3 volts, and the potential difference across the second bulb is also 3 volts. That means that the cell does work to raise the potential of the electron, to raise the potential of the moving charge. When it reaches the bulb, the charge then does work on the bulb in order to increase its temperature, making the bulb glow and therefore emitting light. So the cell does work on the charge to raise it to 6 volts, and the first bulb, the charge does work on the bulb, lowering it by 3 volts, and then on the second bulb, also lowering it by 3 volts. So let's look at a circuit in a simpler form. If we want to measure the potential difference across the different components in the circuit, we'll start by looking at the cell. We place a voltmeter across the cell, where one connector is on the left-hand side of the cell and the other is on the right. If we find that we have 6 volts of potential across the cell, we can then test the potential across the bulbs. In this case, we place the voltmeter across one of the bulbs, we get 3 volts, and the voltmeter across the second bulb, we also get 3 volts. So since the cell is raising the potential of the electrons in the circuit, and the bulbs are lowering it, we can see that the cell provides a potential difference which is equal to the sum of the two potential differences of the components. So the cell raises the potential of the electrons, and the components lower them back down to 0. If we consider a similar circuit, we don't want to assume that the potential is always shared equally. In this case, the potential across the cell is 6 volts, but across the buzzer, we may find that the potential is only 2 volts. That means the potential across the bulb must be 4 volts. That is, the 6 volts across the cell is equal to the 2 volts plus the 4 volts across the two components. Again, we see that the potential difference across the cell is equal to the sum of the potential differences across the different components.